I don't think I posted the solution to the test yet, but I should by the end of today. All right, so I should have a solution as well as a blank copy of test 2 to study. All right? Yep.
Can I ask a question about the homework?
Yeah, you can ask a question about homework. I was about to go do a bunch of homework problems, but sure, go for it. Which one? Which number is it? Week 11, right?
Yeah. It is. It's question 13.
Yeah, we can solve something like that. Sure. Was your question just how to work it? Yeah, sure. So example 1 will be number 13 from week 11. At least, I think these are randomized. I'm going to solve the one that's in my homework, okay? So I've got 3,000 is equal to 1,000 times 1 plus r to the 26. Now once we get through this one, I'm going to backtrack and do a bunch of more simple problems. I think I still need to do a bunch of kind of simple problems from this homework that I haven't done yet. So let's see here. Yeah, we're good. Oh, and lest I forget, let me begin with a word of prayer. So here we go. Dear Heavenly Father, we thank you for the beautiful weather outside. I thank you for these students. Just ask that you bless our time today. Help us to glorify you, what we do, and help us to understand a little bit more about your creation together, Lord. In your name I pray. Amen. And again, I know some of you have, pretty low scores on test 2. And so there's some kind of like severe bifurcation going on here. Like the grade distribution probably looks something like this. So like here is 120 to 165, bunch of scores in here, and then there's a bunch of scores down here, like, and I don't have like a lot of in between 85 and 120. There's like a bunch of people who are on the borderline, and like if things don't improve, you will not pass, unfortunately. I think there's still time. I will replace test 2 with your final exam grade if you improve. Now there are other people, I haven't like done a line-by-line comparison of all the grades in here. Like I think there are people who have improved their grades over test 1, right? Yeah. And like that is possible, right? But there's some of you who it didn't go well for on test 2, right? And I understand that. But all is not lost. I will replace your test 2 grade with your final exam grade if it's better, all right? But you do need to, figure out what went wrong and address it. Yeah.
Isn't the final exam like 200 points though? So
It is, but I will substitute the final exam score for your test score if it helps you.
Okay.
So, in principle, how much is the final exam score? You said it was 200?
200.
And the tests are what, 150? Right? So, I've already told you I will substitute test 1 and test 2. I'll do both actually, if they're better. If the final exam is better than your test 1 or test 2, then I'll replace the final exam grade for test 1 and test 2. Yeah, so that means that your final exam could, in principle, if you do better on it, be worth a much larger percentage of your overall score. Yeah.
If, like, let's say we did good on test 1, but didn't do as well on test 2.
Uh-huh.
Will we still get to keep test 1? Or
Oh yeah, yeah. No, I never like. I'm, as a general rule of order, if I'm modifying a syllabus, I only modify it in such a way to help you. Like I don't be like, well, since I'm, I don't know, since I'm counting the final more for some people, I guess I have to count it more for everybody. It's never a thought that crosses my mind. Like once you have earned a good grade on a test, that is yours to keep. All right, that is your get out of jail free card for the final. Let's say. What's that? The final is cumulative. It'll be about 30% test 1, 30% test 2, 30% test 3, ish.
Okay.
And but as you know, and as you probably have experienced, there is overlap, right? Is test 2 not covering test 1 material? No, I mean a lot of you got test 2, the last problem wrong because you couldn't factor that polynomial, right? Like, I don't know, I didn't think I was being mean there, but a lot of you were like completely floored by trying to factor the polynomial on the last page, right? So, for example, so if you're weak in factoring, you should go back and like dwell on that. Do all the problems in the textbook, you know? Okay, so let's work this problem. I think the first order of business here is to divide both sides by 1,000, right? Because it's just, I mean, come on, it just yells at you. Divide by 1,000, right? Do you agree? I think that would make life easier. So this is 3 is equal to 1 plus r to the 26th power. All right? Now, what are properties of exponents? We have, you know, a to the x times a to the y is a to the x plus y, right? We have a to the x over a to the y is equal to a to the x minus y. And what else do we have? We have a to the, let's say, s raised to the t power is a to the st, right? And there are other things, right? Like, and here's something to always watch out for. If you ever have a to the n, one of the things you can do is raise it to the 1 over n power, and what do you get? You're like, what's that? I mean, this is the nth root of a to the n. So what's that equal to? So we multiply it, right? N times 1 over n, and we get a to the 1, which is equal to a. And at this point, you might be like, whoa, 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 whoa. That's not what you said like a week ago, because like a week ago, you made this big to-do about even roots being different than odd roots, right? Didn't I do that? Remember that? So, like, this is what? This is absolute value of a, generally speaking. I mean, case-wise, right? So this is either equal to a if n is odd, or it's the absolute value of a if n is even, right? For example, the square root of a squared is not a again, it's the absolute value of a, right? So I should mention that these laws of exponents, when I write them like this, I'm assuming something about a. What am I assuming? This assumes what? This assumes a is positive, right? Otherwise, I have to deal with the plus minus issue for the even roots. And so then the question I have for your homework is your homework thinking about that? Yeah? I don't know. Let me look at mine. I have the key. Let's see if there are 2 answers or 1, because I think there should be 2. Are there 2 answers? No, they just got 1 answer.
Oh, I ended up getting it wrong and it gave me another one, and it ended up being like 2 answers.
2 answers. I mean, I think there are 2 answers. Let me show you why. So to solve this, I just take the 26th root of both sides, right? So like the 26th root of 3 is equal to, you know, plus or minus 1 plus r then. I should say it the other way. I usually put the plus minus over here. Sorry, my bad. It doesn't matter which side you put it on, but I usually put it on the other side. So if I take the 1 over 26th root of both sides, I really should have plus or minus. So this will give me r is equal to, you know, minus 1 plus or minus the 26th root of 3. But I think your textbook, I think your textbook, what's that? I'm pretty sure that the textbook for the answer here is just looking for minus 1 plus the 26th root of 3. Or you could write it this way, 3 to the 1 over 26th power. And so what's that equal to? Like, I don't know. What number, when you raise it to itself 26, when you multiply it by itself 26 times, do you get back 3? I personally cannot do that in my head. I don't know about you. Okay, that's not true. If I had some time, I could do it. But because there's ways to do this with calculus, truth be told. But without calculus, we're up a creek for sure. 3 to the 1 over 26 power is, so here's minus 1 plus 1 point, I'm going to keep about 6 digits here. 104, 1, 5, 9. This is all my calculator gives me, okay? That's it. 1.04315974. I don't think we need all of these. Did the instructions instruct you to do to a nearest hundredth or something, or?
Integer or decimal rounded to nearest hundredth.
Nearest hundredth. So 100th is this guy. So the answer would be, I believe, 0.04. But there's a -1 there.
Oh, yeah.
Oh man, I don't have the key on this. That's unfortunate. Oh, yes I do. Yeah, the answer is 0.04 in my book. Okay, so anyway, I would point out that technically speaking, this is one of two answers, because you could do plus or minus this. I would point out that the book is wrong. You could say or, you know, minus 2.04, you know, that's also a solution here, I believe. See, because if you take minus 2.04, you plug it in here, you add 1, you get minus 0.04, which when you raise to the 26th power, it gives you about excuse me, what I'm trying to say here is minus 1.04 raised to the 26th power is also very close to 3. So that's another solution. When you plug in r equals to minus 2.04, there really are two answers here, even though the your MyLabs is only looking for one answer. All right? Sometimes the book is not that careful. Sorry to say, but it's true. Example 2. No, please no. That is a thankless job. I have written lengthy notes for other classes, and then I get accused of writing a book. And then you have a book, and then you have notes, and then they're like, "You're making us read 2 books." There's no winning. Okay, so although you're right, I really should write notes for college algebra. I do for all my other classes. I don't know why I haven't for here yet. I guess I'm just lazy. Let's see here. Let's work an easier problem. What's that?
I have a problem.
Yeah? Which one?
Number 11.
Okay, we're going to have to come back to that. I need to work about 5 easy problems, then I'll come back to your number 11, okay? So, because otherwise what's going to happen is I'm going to work all of the complicated problems, and then all the people who haven't started their homework yet are going to be like up a creek, yes. But I do want to get back to your number 11. Don't let me forget about it, okay? So let me forge ahead here as fast as I can. 1/5 to the x equals to 625. How do we do this? The easiest way to do this is go, oh, well, let's see here. Like, there are different ways to approach this. How do you guys want to do it? Yep.
Can you like find what 625 is? You know?
What do you mean find what 625 is?
Like what number to the exponent power?
Is it like 3 to a power?
Yeah.
Is it 4 to a power? I mean, what power? What are we looking for? I mean, you're not wrong. What is that? So what he's saying is use math magic to go, that's 5 to the 4th, right? Because 625 is 25 times 25, right? And then that's 5 times 5 times 5 times 5. 4 5s multiplied together give you 625. Is this obvious? I don't think so, but there it is. And on the other side, this is 5 to the minus 1, right? Raised to the x power equals to 5 to the 4. Okay, and then by laws of exponents, this is 5 to the minus x equals 5 to the 4. And there's something I don't think I told you guys last time, but I should tell you. Here's a theorem. If we have a to the x equals to a to the y, that implies, or let's say x1 and x2. That implies x1 equals to x2, right? What was this? This was the one-to-one property of the exponential, right? So this we can use to solve problems, right? Whenever you can take the problem that you're looking at and reformulate it as as a number to a power equals to that same number to a power, you can equate the powers. Yeah? So the one-to-one property here tells me what? Minus x equals to 4, which tells me the solution is x equals to minus 4. Now, this is a fine solution if you have a very good number sense, right? If you have a command of powers of 5, right? Now, if you see a problem that's got a 1/5 in it, maybe a good idea is to just calculate 5 squared, 5 cubed, 5 to the 4th, and look at those and see what your problem has and see if you can use those numbers, right? That would be a common sense approach here. But what if you don't have that common sense? Is there another way, a more mechanical way of solving this? There is. Let me show you how. So the other way we could solve this is using logarithms. So example 2, the logarithm solution, let me show it to you. Here we go. So if I see 1/5 to the x power equals 625, all right? That yells at me, it says use log base 5. Or you could use natural log. I mean, you guys, your choice. Log base 5 or natural log, what you want? Log base 5. Okay, so log base 5 of both sides. So we can take the logarithm of both sides because both sides are positive. Be careful. All right. Now, this calculator, the Casio FX115ES, does have log base 5 on it. I found it finally. If you go to, it's the uppermost button here. It's got like a log. You can type a base in. You do log base 5 of 625. Guess what happens? You get that this is equal to 4. Okay? So if you have this calculator, you can do that. All right? And on the other side, we get x log base 5 of 1 over 5. What's log base 5 of 1/5? Well, let's calculate that, right? This one is easier. This one we shouldn't need a calculator for, right? Log base 5 of 1/5 is what? It's log base 5 of 5 to the minus 1. By definition, that is minus 1, right? This is one of the properties I shared with you last class, right? So that's minus 1. So put that back up in here. We got what? We've got minus x equals to 4, so x equals to minus 4. So the second solution, let me call it example 2 tilde. What's the difference between example 2 tilde and example 2? The difference is example 2 tilde is not clever. I just took the logarithm of both sides, right? Now, what if you don't have this calculator and you can't calculate log base 5? What do you do? How do you operate? What do you got to do? See, another thing we could have done to solve this problem, example 2 tilde tilde, 1/5 to the x power equals to 625. So suppose you don't have log base 5 on your calculator. Another thing you could do is just take the natural log of both sides. You can still take it, natural log of 1/5 to the x power. It's natural log of 625. And so this gives me x times the log of 1/5 equals to the natural log of 625, which I solve for x. And I've got natural log of 625 divided by the natural log of 1/5. Now everybody has a calculator in here. Everybody has a calculator in here that can calculate natural log of something. You need to have that for this next test. It's not optional. You must. Yeah? Oh, thanks. I didn't see it. It's all good. And so when you plug those into your calculator, out pops minus 4. All right? Yep.
In your second example, too, where did the x go from when you have x log base 5 1/5 to the next step?
That is the property of logarithms. Remember one of the
So then where's the x in the step after that?
Oh, this one. Yeah. So here, all I'm doing here is I'm figuring out that it goes right here. And then down here, I put minus x times minus 1. Here, if you like, x times minus 1 equals to 4, and then x is equal to minus 4. I was just, fair enough. Sorry about that. Don't mean to confuse.
What did you call that kind of thing?
Which one?
When it looks like the crest logo.
Oh, this?
Yeah.
That's tilde,
So,
which I believe is written like this, for what it's worth. I had an advisor who, he always, if he found that he was using two letters at the same time meaning two different things, he would always just go back through whatever he's writing and just add tildes to all the ones he wanted to be different. So I don't know. I add tildes to things in honor of Dr. Fulp. I will say that. Okay, so let's look at another example here. How about, and I think now is a good a time as any to look at your number 11, so let's do that. Number 11, so it's example 3, which is number 11. This is kind of a break. So here you have f of z equals 18 to the z power, passes through points. So they got you filling in some blanks here, right? So they got like -1, fill in the blank, right? 0, fill in the blank. And 1, fill in the blank. And what else? Oh, that's it. Okay, so I'm sorry. I glanced at this problem and I thought it was complicated, but I retract that statement. This is not a complicated problem. This is just straight up function evaluation. All right. So, what is the graph? What's the graph of a function look like? It has pairs where we have input, output, input, output, input, output. Right. So this means input -1. Right. This means we input 0, right? Input 1, right? Think of the function as a machine. It takes in z in this case, and it outputs f of z, right? 18 to the z power. So this is in, out. So what is f of -1? We do 18 to the -1, right? Which is just what? 1/18th, yeah. F of 0, 18 to the 0 power, which is 1. And then f of 1, which is 18 to the 1 power, which is 18. So those are what go in the blanks up there. You know, 1/18th, 1, and 18. Oh, something I think I haven't done for you guys yet, but I probably should, is to graph one of these things, yeah? Let's look at a graph. And we'll come back to these equation solving, all right? We need to do a bunch of those. So I'm going to just keep solving equations, but do need to take a brief break here and graph for a second before I get back to the equation solving. So example 4. Let's try to graph y equals to 3 plus 2x minus 5. So I would graph this using transformations of graphs, all right? How's it go? What does the graph look like? So what we're going to do is we're going to take the y equals 2 to the x graph, which looks like this, right? That's y equals 2 to the x. We learned that before. We looked at it on the Desmos and such. And I think if we just track a couple of features, let's track 3 features, right? There are 3 interesting features, perhaps. Like this is the horizontal asymptote, right? Y equals 0. And there's a y-intercept right here, right? That's 0, 1. And then over here, you've got the point 1, 2. Because when we put in 2, we get 2 to the 1, which is 2. Yeah? And to get this graph, what do I want to do? shift what? Up 3, right? And also what? Right 5. So if I do that, shift up 3, that's going to move my horizontal asymptote up to 3, right? And what's going to happen to the y-intercept? Where is it moving to? Think about it. I take 0, 1. I go up 3, right? That takes me up to 0, 4. I go over 5, so I go 5, 4. So roughly speaking there. So over 5, up 3. 1 plus 3 is 4. And then the other one shifts over to here, right? That point would be 6, 5. And then there it is, something like this. That's the graph of y equals 3 plus 2 to the x minus 5.
So you're saying the 3 in the front only moves the horizontal asymptote up? Okay.
Well, it moves everything. It moves the graph as well, but I think it's most noticeable on the horizontal asymptote. I mean, it's moving every point up 3, right? And then the replacing x with x minus 5 shifts us 5 to the right. This is remember the transformation to graph idea we talked about a few weeks ago? Yeah.
If it was 3 plus 2x, would that be different?
3, if I had 3 plus 2x. Yeah, if I just had 3 plus 2x, it would just look like this would be y equals 3 plus 2 to the x, would look something like that. So then the y-intercept would just moved up 1. Well, moved up from down here to up there, from 0, 1 up to this point, which would be 0, 4. But this one, we took that point, and then we took the red graph, and then we shifted it 5 to the right. You know? So there are some graphing questions in your homework. They can all be understood by just transformations of graphs on the basic function. Yes, sir. Wait. Number 16, you having trouble with that one? Sure, we can look at that one. Let's take a look at that. Let's see here. Oh, this is pretty much that problem, though. Number 16 is this problem. Pretty much. I mean, it's the red problem. For me, anyway. I mean, maybe you got a different one. I've got f of x is equal to 6 to the x plus 3, right? Something like that. And then you're supposed to find the domain and the range. So essentially, I go, okay, well, that's the y equals 6 to the x function, right? But I'm shifting up 3, right? I go up 3, and then it's y equals 6 to the x, so it looks something like this, basically. That point, so this, I'm not doing it very carefully, right? This is 3. This point should be 0, 4. If I was careful, this point right here, like when I get to 1, I've got 1 comma what? 1 comma 9 would be that point there, for example. And let's ask the question for both example 4 and example 5. What's the domain for example 4? So the domain of f of x here, everything, right? The domain here, also what? Everything. What's the range? So the range is the possible y values attained by the graph, right? So look at the black one. That's the one we're talking about here. It starts at 3. It's not actually at 3, though, right? Mm-hmm. So 3 is not included, and it just gets as big as you want. So 3 to infinity. This one's also 3 to infinity because it's also a plus 3. So the range here. Does that answer your question about 16? Yeah.
How do you know when it's included?
It's included if there actually is a point on the graph which gets to the asymptote. And if there is such a point, then fine. But if there isn't, then no. So, I mean, specifically, you can try to solve the equation. We have 6 to the x plus 3 equals to 3. That would it would take this equation having a solution if we were going to include 3, right? What does this equation give you? This gives you 6 to the x equals to 0, right? Is it possible to have a non-zero number raised to a power and get 0? No, it's not, right? So there is no solution to this equation. No solution. So like something to know about exponential, something to keep in mind is that a to the x is always positive. Like that is one of the critical features of the exponential function is it's non-negative, no matter what the input is. Yep.
Okay, so you said that the horizontal asymptote is always affected by that number. To find the vertical one, I know you taught this like a week.
Oh, there is no vertical asymptote in this.
But if there were to be one, what would it look like?
Well, for exponentials, there's not going to be a vertical asymptote, so I'm hesitant to answer that question. Now, if you want me to bring vertical asymptotes into the game, we can talk about logarithms. See, because logarithms are the inverse function to the exponentials, right? So logarithms take those horizontal asymptotes from the exponential type functions, and they turn them into sort of vertical asymptotes. So like, for example, let's see here, 7, 6, 6, right? If I had y equals to, let's say, 2 plus, log base 3 of x, then there's a vertical asymptote. So like I start out, the way I think about that is basically just this. Log base 3 of x looks like this. It's got a x-intercept of 1, 0, right? And so this graph, roughly speaking, and I can pick another point. Like what's log base 3 of 3 equal to? It's equal to 1, right? So the point 3, 1 is over here. If you keep going. So I can take those 2 points and I can shift them up 1. That'll get me the graph. So I just take the graph of logarithm and shift it up 1. That's this graph, yeah? So this 1, 0, and my graph is probably not to scale or anything, but oh man, rats. Well, sorry, this is not to scale by any means. So something like that. This point would be 1, 2, and this point over here would be 3, 3, I think, if I added 2. I'm just adding 2 to the y. I'm shifting up 1. What's the domain and range here? Yeah, if I call this thing f of x, I've got the domain of f is like 0 to infinity, right? And the range is what? It keeps going down and down here, and that keeps going up and up. It never levels out. It keeps going up. Somebody have another question they want me to work? Yep. Far into it. I hope it's not a graphing question. Let's see here. I want equation questions. Let's see here. Oh, okay, good. Yes, thank you. This is the kind of question I was hoping for. Example 7. So this is not an equation question. This is an expression question, all right? And there are a bunch of expression questions in your homework, and the point of these questions is for you to, this is example, for me, what was it? This is number 39, but example 7. Not that it matters, but so my example 7 will be like number 39. Your number 39, my number 39 looks like this. Log base 2 of the square root of 7 r to the power 5 divided by z to the power 3. And what we're supposed to do is to use properties of logarithms to rewrite the expression, simplify the result as much as possible, assume all variables represent positive real numbers. And, or you're supposed to say the expression cannot be simplified, all right? So here, alternative, before we do this one, here's one that could not be simplified. Check this out. If I had like log base 2 of a plus b, if that was the expression, then I would check like second thing, expression cannot be simplified. That would be what I would mark for this one. So this does not simplify. I think I made, actually I told you guys about that last time, didn't I? So yeah. Okay, so log of a sum is nothing nice. This one here though, what, can you tell me what can we do here?
So, I thought we were supposed to split it.
I think that's right. So this is z r to the 5 over z cubed to the 1/2 power, right? So I can pull the half out, right? And then I have z r to the 5 over z cubed, like that. I'm going to leave the half out front. And then I can do, I've got log of 7 plus the log of r to the power 5, and then minus the log of z cubed. So using the properties of logarithms, right? Product gives you sum, division gives you subtraction, but then what else? Powers pull out, right? So I can simplify this further, and I have the following. I have 1/2 log of 7 plus 5/2 log of r minus 3/2 log of z. And so I would say that's probably the answer they're looking for there. But, I mean, honestly, they really should accept multiple answers, because what is simplified is kind of in the eye of the beholder here. Some other people might insist that you write that as like the log of the square root of 7. I don't know. But this is certainly, that's what the homework's looking for anyway. Yep.
What happens to the 2?
It's right here. I multiplied it through.
No, I meant like the 2 by the log.
Oh,
Because of the fracture.
I wrote it in white.
Oh,
Let me change the font. See here. Sorry, I'm an idiot. All right. I'm a dad. I'm allowed that joke. Let's see here. All right. So you guys have managed to ask about like a really bizarre collection of homework questions today. So let's work another one. Number 25. This will be my final example for today. Mine. So here we're faced with the square root of 2 raised to the x plus 8 power equals to 4 to the x. All right. How do you solve this? I think this one says to me, I want to look at everything as powers of 2, right? Because 4 is 2 squared. I think we all know that, yeah? So if I use that, I have 2 to the 1/2 to the x plus 8, right? Equals to 2 to the 2 to the x. Right? And then I can use laws of exponents. That gives me 2 to the x plus 8 over 2 equals 2 to the 2x, right? And then, by the one-to-one property of exponential, this gives me x plus 8 over 2 equals to 2x. And then I solve for x, yeah? So this gives me x plus 8 equals to 4x, which then gives me 8 is equal to 3x, which then gives me x is equal to 8/3. So if you guys want to see more examples like your homework, I worked another 10 problems in this homework in section 4 Wednesday, right? So if you look at section 4, if you look at the video from Wednesday there, you'll see I solved about 10 other of your homework problems in there. And we've managed to cover really different problems in there than we did in here. So it's almost not overlapping at all.